Hello, my dear students, and welcome to our chemistry class for Thursday. I want to introduce our next topic, which is writing uh, formulas for covalent compounds. Previously, we did naming ions, and then we did naming and writing formulas for ionic compounds. Now we're doing writing and naming formulas for the molecular covalent compounds. So, if you want to follow along or review or go back to what I'm covering, if you go into your Google Classroom stream, you will find that I have included these notes and review information and sample questions for you. You may just go in and open it up. If you do so and open it again, and then using your three dots, you can download it and open it in something other than Google Slides, which is what I've done. I'm going to go to my presentation program for the iPad, which is Keynote, and go to our lecture notes right here. And I will quickly review our topic, which is naming and writing formulas for molecular compounds. And I will then briefly go over the assignment where we review the concepts and terms to try and solidify them and help you, cement them into your knowledge base. So, they open with a little discussion of prefixes or prefaces, however you wish to pronounce it. And prefixes are important, and we're going to start using prefixes in our compound names when we go to molecular compounds. We've used prefixes before. For example, the metric prefixes milli and kilo, and they mean quite a bit of difference. A kilogram is about 2.2 pounds, and that's 1,000 grams. A milligram is 1/1000th of a gram, and that amount of gold is worth about a penny. I passed some gold foil around in class, and you saw how thin gold can be, how malleable gold is, and into what thin sheets it can be formed. But a kilogram of gold would be worth probably double that now. This is an old slide. I'd have to look up the price and see. But the point is the prefix, and using the correct prefix is very important to what we do. So the question is, what prefixes do we use, and what do they tell us about the composition of a compound? And what we're going to use prefixes for is describing the number of different atoms in a molecular compound. Two very common molecular compounds are carbon monoxide and carbon dioxide. And carbon dioxide is something you're breathing out right now, and if you're in a room, it is accumulating, and the more people in the room, the more it accumulates, but we never worry about it accumulating to hazardous levels because, for one thing, we're producing it all the time, and it is present in relatively small amounts and being metabolized continuously. Carbon monoxide, on the other hand, and we've had some tragic deaths in Texas where people have tried to burn wood in their house without venting it properly, or cook or heat using charcoal grills in their house without proper ventilation. And carbon monoxide has built up, and sadly, it is a toxic, extremely toxic gas. It's odorless, colorless, and its effects are cumulative. It binds to your hemoglobin and inhibits oxygen transport, and it binds very tightly and does not let go. So it continues to bind and accumulate and has a cumulative effect that is frequently fatal. So The difference between the two is quite dramatic, and yet the only difference is one has two oxygens, one has a single oxygen in its formula, and the carbon monoxide, mono, meaning one, is the one with one oxygen. Carbon dioxide, the common gas that we exhale as a product of our respiration and that plants take in to perform photosynthesis, is has two oxygens, di meaning two. And let's look at those Greek roots. These are Greek prefixes, Greek roots for the numbers mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And you have met many of these before. The Pentagon, which is the headquarters for the military, or hexagons and hexagonal arrays when you talk about, I don't know, I'm thinking of it in terms of protein structure and the coat proteins of the COVID virus. But octa, we know the octagon and the stop sign, and we have octane gas, which is on average 8 carbons long. Nona, deca. So you've heard of most of these. Let's see. There are Latin cognates as well. For example, di is Greek and bi is Latin. But mono is Greek and uni is Latin, for example. But we're going to use the Greek prefixes to tell us how many of each type of atom is present. So, we name the elements in the order in which they're listed in the formula. And, like carbon monoxide, CO, and we use prefixes to indicate the number of each kind of atom. There are notable exceptions. We don't use the prefix mono when only one atom of the first element is present in the name. So we don't say monocarbon monoxide, though people would understand you if you said it. The mono is understood. And very frequently, even the second atom may not include the mono. It's important when we discuss carbon monoxide because carbon monoxide is it's such an important distinction to make between it and carbon dioxide. And of course, as you may have noticed from our example, that the suffix of the second element becomes ide, I-D-E. The same way we changed the suffix of negative ions, anions, to ide. For example, changing chlorine to chloride when it becomes the Cl minus anion. So we'll practice a couple things and then go straight to our assignment. So how, given the name of a binary molecular compound, do you write the formula? Well, you use the prefixes to tell you how many of each type of atom is present in the formula, and you simply write the symbols for the elements with appropriate subscripts. Silicon carbide, so we didn't say monosilicon. We could have said silicon monocarbide, but it has its name. It's an unofficial name of silicon carbide. Its official name would be silicon monocarbide, but it's in such common use that we go with silicon carbide, a very common substance used for sandpapers and grinders and things like that. Very hard substance. We've discussed it before, but its formula would be silicone, Si, carbon. SiC, silicon carbide. And we didn't have to say monosilicon, monocarbide. We knew it was understood. In addition, this formula does not require the ones for subscript. They are understood, so we're not going to use them. We'll look at some other examples. So these are great, like I say, potential test questions. Which of the following compounds is named incorrectly? So carbon disulfide, that's correct. Boron trichloride, that's correct. Iodine heptafluoride, that's correct. And phosphorus hexachloride, that is not correct because hexa means 6, and we have phosphorus pentachloride, which is actually not an uncommon chemical used for, mainly, I guess, for instruction in the chemistry lab. So if you look at a few more examples, there's only 2 more, and then we'll go straight to our assignment. You have the same sort of question. Which of the following molecular compounds is named incorrectly? I like this kind of question because it very quickly allows me to test 4 different things. But here's antimony. The symbol is Sb. Trichloride. That's correct. And carbon pentoxide. Dicarbon pentoxide. So see, we didn't say monoantimony trichloride, because the mono here is understood in the first example. But here, when we have 2 carbons and 5 oxygens, it's dicarbon pentoxide. Carbon tetrafluoride would be CF4. And so this one, since the other 3 are correct, must be wrong. Let's see. Hydrogen arsenide. So this should be trihydrogen arsenide. And that anything above mono, of course, is not understood. And finally, what's the correct formula for tetraphosphorus trisulfide? So that would be, phosphorus's symbol is P, 4 of those, and sulfide, the -2 charge, is, but this is not an ionic compound, so this is different. Trisulfide would be 3, so it would be P4S3. And, some of these are reversed. This one's just the reverse, but we're going to write it the way it's named. That concludes our discussion of the topic, but now let's put it into practice. Go back to our class stream, and you should open up your classwork and see that I now have a new assignment, review of terms and concepts for naming and writing formulas. And if you open that up, and I'm at a point where I cannot use my Apple Pen, but here in this Google platform, but if I go ahead and share this, make a copy and share it, send a copy to, or here, or go back up here, or open in another program. Here we go, open in something else. Then I have choices in which I can open it. For example, I can open it in one of my PDF reading files. And this time I'm not going to write and type everything down. I just want to go through and discuss these answers and have you listen and then have you write them down. But let's just go through and go through this review of terms and concepts. So, starting with question number 1 here. Make it as big as I can. Binary molecular compounds are composed of 2 non-metallic elements. So number 1 is non-metallic. And this type of compound ends in "ide," I-D-E, when we name it. So 2 is "ide," I-D-E. Prefaces or prefixes are used to show how many atoms, so number 3 is atoms, of each element are present in a molecule. For example, the name of As2S5 it would be called diarsenic pentasulfide. Diarsenic pentasulfide. Now in the true-false, let's see, I have 3 conditional true-false here. Binary compounds contain carbon, like the carbon disulfide, but sometimes they do and sometimes they don't. So 5 is ST, sometimes true. And charges must be balanced in writing formulas for molecular compounds. That is never true. These are not ionic compounds where we're trying to neutralize the charge. We have different bonding here. We have covalent bonding, and we're following different rules. So that's never true. And CO2 is named monocarbon dioxide. That's never true. The mono in the front is understood. You'll see a few jokes out there about people calling water, and that's its official name, but if you were to follow the rules, the official name for water would be dihydrogen monoxide. But you can take this a little too far when we have common compounds and trivial names for them. Anyway, the previous one, number 7, was never true. So let's talk about the matching. A binary molecular compound, number 8, corresponds to D, monoionic compound containing atoms of 2 elements, so 8 is D. Number 9 is A. A prefix is used to indicate the relative number of atoms of an element in a molecular compound, so 9 is A. Number 10, mono, of course, is a prefix meaning one atom, meaning one, but for our purposes it means one atom of an element in a molecule, so 10 is B. And 11, tetra, of course, is a prefix indicating 4 atoms of an element in a molecule. So 11 is C. So 8, 9, 10, 11 would be D, A, B, C. And now it asks us, here's the real, did you get it? It asks us to name some compounds and then write some formulas. So number 12A, there's PCl5. That would be phosphorus pentachloride. Phosphorus pentachloride. Again, if you have trouble with any of these elemental symbols, it might be handy to have a periodic table in front of you. SO2, and again, this is the smell of Pine Bluff when you drive into it, is sulfur dioxide. Sulfur dioxide. It's also the smell of rotten eggs. So SO2, 12B, is sulfur dioxide. We spell sulfur with an F, not a PH like the English, though I'll accept either answer. And finally, 12C has P4S10. That would be tetraphosphorus decasulfide. So tetraphosphorus, as in tetrahedron, which has 4 sides, tetraphosphorus decasulfide. Deca, like in the term decade, which is 10 years. Deca means 10. So tetraphosphorus decasulfide for 12C. And then the last two, and we're done, has carbon tetrabromide, and that would be CBr4. That 4, of course, would be a subscript. So it would be C for carbon, monocarbon, Br4. And dinitrogen tetroxide would be N2 for 2 nitrogens, O4 for 4 oxygens. So 13B is N2O4. And of course, the numbers are subscripts. Well, that concludes our coverage for this topic today. And I will see you back here on another screencast tomorrow. Until then, stay safe. We have no school Thursday. We have no in-class open building school. Of course, there's still instruction, this being it, Thursday and Friday. And for my face-to-face students, the current information I have is we will not have a virtual Monday. We will meet face-to-face on Monday for the face-to-face students. Virtual students, I'll let you know if I'm going to be Google Meeting the classroom. It depends on what activity I choose for us to do on Monday. I will make that decision tomorrow. So until then, take care, stay safe, and stay warm.